Let's continue with some other forming processes. These are specialized ones, and obviously they are not frequently used than the other processes the previous discussed topics. Let's focus on one by one. The first one is explosive forming, and as the name applies, we are using some special chemicals, explosives, as a source of energy in this process. So how do we perform this process? We first clamp our sheet metal onto a kind of a die, and obviously after explosive forces applied on this worksheet, on this metal, it will take the shape of our die. But the thing is that we need to evacuate this air inside the die. So that's why we have a vacuum line. And later we put this actually the setup into water so that we don't have much sparks fire in air. And this process is performed actually inside a water tank. And you see we have explosive here. Once they're ignited actually, then we'll have stress compressive forces on the sheet metal and it will take the shape of our die as you see. And this is mostly preferred for larger workpieces, maybe the main part of a ship, a little ship, but obviously this is quite difficult and dangerous. So for small parts, we shouldn't be using explosive forming. Then we have electromagnetic resistance forming. The fundamental idea is the same, just the difference with respect to the explosive forming is that instead of using explosives, we are using magnetics, and you see we are using electromagnetic, and once we apply current, then due to the high magnetic forces, our metal is actually shaped, and we form our metal into the die. Again, the die is important. Our sheet metal takes the shape of this die. Then we have pin forming, and in this process we make use of shot pinning. So we have little actually sand particles. We shot them on the surface and try to bend it. You see that before the process is flat, and once you apply this shot pinning process on the surface, then we will have some curvatures on the surface, and these are obviously due to the compressive stresses applied by these shots, applied by the sand particles. Then we have laser beam forming. It's very simple what we do. With the help of the laser beam, we try to increase the temperature of one specific region, localized region, and with the help of that, the strength in that part is reduced, and we can easily bend that metal or pipe easily with the help of laser beam forming. And if you do these processes in micro scale, then these processes are called as microforming. Then we have electrohydraulic forming, somehow similar to explosive forming, but the difference is that we are not using explosives, but we are using some sparks which are similar to the EDM process. Then let's talk about some other issues about these processes, like actually the equipment. In all these sheet metal forming processes, in most of them, we use some types of presses, and they may be pneumatic type, hydraulic type, mechanic type, but we use such presses to form these sheet metals. You see a C-type here, a white design, so we can accommodate larger sheet metals. And depending on the complexity of your shape, you may need to have a larger opening in Z. That's the thing actually you need to use. Or if you are applying too much forces, you may go with pillar and double column. Since if you apply high force in C frame, then there will be bending in between these, and you cannot increase actually the quality, the dimensional accuracy of your parts. So in such cases, you should go with E or F. There are some example presses. And what is the economy behind sheets metal forming? It's better I focus on deep drawing process. As we have seen, deep drawing process are highly useful, and the thing quite expensive since you need to these dies and tools on your own, and the manufacturing of them are highly difficult. So we don't use them for small numbers of production, but for high numbers, they are quite useful. You can decrease your overall costs in some seconds. You can manufacture, for instance, the same product. So you spend too much at the beginning of the operations, but if the number is high, then you see the drawing is a bit better than spinning operation. And this is all for this chapter. Make sure that, guys, you have a look at the review questions here and also the qualitative problems. And see you in class.